Guys, welcome back. So this is the third part of the playlist, right? And we're going to pick up from where we stopped the last time. And if you remember, in the last video we were able to create a simple rack system. We had a list of contexts, right? And we had a function that basically just do a word match with the list of contexts here. Find the one that has the word that matches the question, right? Then feed that to the LLM and then use that to answer our question. Now we also saw the reason why this would not work in the real world, because it means that if the question does not contain a word in any of the contexts here, or probably we are asking question related, we can ask a question related to something else, and because of the words matches a context that is not even related to that question, it's going to try and fetch that context, and then at the end of the day the bots or the chat bots or the agents will not be able to answer the question. So the question is, how do we find a better way to do a context search that's irrespective of either the words match or not, as long as the question being asked has a corresponding context, the system is going to work. And that leads us to the next two things we're going to talk about: vectorDBs and embeddings. vectorDBs and embeddings. So let's start. What is a vectorDB and how does it help to solve our problem? So a vectorDB, as the name implies, is basically a vector database, a database that is used to store vectors, right? And the next question you'll be asking is that, what are vectors? So I really do not want to go into the mathematics of vectors, right? But vectors are basically some bunch of numbers, right, that mean something, right? So unlike a regular database where you have your data saved in form of text, in a vectorDB all the texts are converted into a vector and then saved as vector. And a vector is basically a numerical representation of the text. Now what does that mean, and why do we have to do that in the first place? Now this is our context DB here right now, right? This is just basically a Python list. This is not an actual database, right? Now this is a string. This is a text that says Daniel is 45 years old. Now this text can be embedded into a vector. Embedding or embedded basically means that we're going to convert this text into a vector. And how does that look like? So we're going to import two new things right now. We're going to import ChromaDB. I'm going to import embedding functions from ChromaDB utils. Now remember, you can install ChromaDB by either running the pip install requirements, or you just do something like pip install ChromaDB, right? And that should solve your problem, right? Or you can use this instead, right? However, I already have ChromaDB installed, so I'm not going to run this. Now we imported ChromaDB and we've imported embedding functions. Now the embedding function here is actually a function that allows us to embed text into vectors. So I can say something like em equal to, let's get so ChromaDB provides us with an embedding function, right? And we're going to use that function to embed default EF here. Okay, we're going to embed, see, our context DB. Let's take something from our context DB and let's embed the very first word here, which is 45 years old, right? That is 45 years old. So you run this, it takes some seconds, but at the end of the day we're going to get a vector that represents that text. So that vector will be saved here, right? So now we can view the vector. So now you can see that this is a bunch of numbers, right? This is actually a vector, right? But this number is actually a numerical representation of what that text says, which is Daniel is 45 years old. Now why is this even a thing, and why is this even important? Now the interesting thing is this. Now whenever you embed tests and represent them as vectors, right, it is easier for you to perform mathematical operations on them. It is not really possible to perform mathematical operations on strings, right, but we can perform operations on mathematical operations on vectors, and it means that we can do some pretty interesting things. And one of the interesting things we can do is something called a semantic search, right? And I'm going to show us that shortly. Now a semantic search is basically taking an embedded text, right, and comparing it with other embedded tests to find which one of these tests has similar semantic meaning or semantic similarities between these tests. So for instance, we can embed all these tests here, right, into a vector, right, and then whenever a user asks a question, we can also embed the user's question and then perform some mathematical operation to find which of these questions has very similar semantics to any of this. Now I wouldn't go into the mathematical aspects of semantic search in this tutorial, and sincerely we do not even need to know, because ChromaDB is going to do everything for us. So let's do that. So the first thing we want to do, like I said, ChromaDB is basically a database that is used to store vectors, right? So the first thing we want to do is to embed all our data here and then save it into a ChromaDB instance. So how do we go about that? Pretty simple, right? I'm going to copy a piece of code here and I'm going to explain the code. Now what we're doing here, we are creating an instance of a ChromaDB client, and we are using the persistence client coming from the ChromaDB module, and we are setting a path called context. Now this context can be anything, right? It could be anything, it could be any name, but basically this is just the name of our database. And the persistence client is basically saying that I want this database to be saved, you know, persistently on my system, saved in a folder, saved in a path called context. So we are creating a database and we're saving that database as in a folder called context, basically. Now when you create your database, the next thing you want to do is to create a collection. So a collection is basically like a folder within your database that you can use to save similar data. So it's basically like, you know, if you are working with Postgres or SQL, or so let's say you're working with Excel. In Excel you can have different Excel tables, right, and each table can save different kind of data. So think about the collection as table in this scenario, right? So you can just create a collection under your main DB. So in this case I'm creating a collection called Daniel because I want to save all the information of Daniel inside this ChromaDB collection, right? And then we are using the embedding function default AF, which is this function. So what it means is that whenever we try to save a data into this collection, that data is going to be embedded and then saved here. So we're going to run this, and now we've saved. You can see that immediately a new folder was created here. This folder was not here before, but it has been created already. So we have a folder called context. Now this is where all our embeddings will be saved. Now we've also created a collection called Daniel, right? So now we have an object here that gives us access to this collection within this database here. Now we're going to say db.add, and we are going to pass in some documents. The document is basically a list of string, which is this guy that we want to embed and save into the ChromaDB. So in case you've not figured out what we're trying to do yet, ChromaDB is an example of a vectorDB, and it is free, open source, and you can use it without internet access also, right? There are other types of vectorDBs. There are some that are not free, but this is free and it works really out of the box, really interesting, right? So documents here is going to be our context DB. Alright, and there's one more thing we have to specify when adding documents into our vectorDB. We have to specify the IDs. Now the IDs is basically like the unique numbers we want to attach to each document, right? In our case, we have 1, 2, 3, 4, 5, 6, 7, 8. We have 8 documents we want to save, right? So we have to have an ID that is also 8 in number. So we can just do 1, 2, 3, 4, 5, 6, 7, 8, right? So it means that the first document will give an ID 1, second document will give an ID 2. There are other ways to do this, but let's keep it this way for now. So I'm going to run this code, and we are getting some errors here. Let's see what the error says. Now the error says expected ID to be string. Okay, fine. So the IDs has to be a string. So now we have to change all this to a string. So let's change this to a string. So I'm just going to use my AI editor here. Good. So this is exactly what we need, right? They have to be strings. So now we can try and add this document with these IDs to our database. Now the moment you run this, you realize that the collection has been created here under context, and then we have some data under context here. So now what it means is that we have taken this context DB, which is basically 8 documents or 8 strings, embedded them and saved them as vectors into our database. Now what does this mean? Now let's say we want to find, we have a user question that says so let's just this way. Yes, we have a query. It's called a query basically, right? That says what does E do? Now we can actually say db.query, and we're going to pass in query tests. I'm going to set that to the query, right? And one more thing, we have to also specify the number of results we want. So we can say 2, 3, 4, it doesn't matter. This is just the number of documents that the query is going to return to us, and whatever documents that is returned to us would be the documents that has the same semantic meaning or semantic similarity to this question. So let's set this to 2 for now, and then let's say results equal to, and then let's run this. So once we run this, we can now print out our results, and we can see that we are getting 2 documents that is being returned. So what happens is this: the ChromaDB went into the data saved inside the collection Daniel, right, and compared every data with this query here and say, okay, fine, in this data that I have, which of these has similar semantics, or based on my semantic search, which of these is the most related to the question asked? And when it did that, it concluded that Daniel works in tech and Daniel enjoys hiking and reading are the 2 contexts or documents that are best related to this particular question. Now this is very interesting because this is way more advanced than what we did initially here, where we are trying to match words. Because if you take a look at this question here has no word that match any of the word here. The same thing happens to this, yet the system was able, ChromaDB was able to do a semantic search using AI and some other mathematical operations to find the best documents that relate to that question or to that query. So now we have something that's going to work irrespective of how the question is structured. So for instance, I can say, let's look for something much more interesting or difficult. Let's say so let's test this, right? Remember, when we ask how many years old is Daniel, this was able to work fine because years old can be found in this place, right? So this algorithm was sufficient for that kind of question. But if we change this to how many years, or how long has Daniel been on Earth? How long has Daniel been on Earth? Now, if you ask this question, remember we're using old llama, we're using llama 2 here to ask this question, and you can see that for some reason this so this is actually very strange, right? And this is actually very, very bad if you think about it. So it says for some reason we ask how long has Daniel been on the Earth, right? And for some reason the system decided to use Daniel has 2 children as a context, which is this, and that's probably because, yes, so I've seen the reason, right? That's because this as and there's an as here, right? So this was the first context that as similar was according to the question, right? And that's the reason why the system decided to use that as the context, right? So you can see that's very, very bad because looking at that context doesn't answer our question. But that's not even where the problem stops. Now, because we're using llama and llama is not as efficient as GPT-4, you can see that even providing just this context, for some reason llama has assumed that Daniel is 27. Okay, so we already said at least 27 years, right? Because if Daniel has 2 children, then definitely he must have at least spent 27 years on Earth, which makes sense. As he was born now, the question now it's saying as he was born in 1994, he has 2 children in 2018 and 2020. I mean, where is all this information coming from? This is just some assumptions, right? So let's change this back to GPT. So we're going to use LLM instead of LLM2, right? And let's use let's use GPT-4, right? So instead of that, we're going to do, or let me just do this, right? Let's just change this to chat open AI. Okay, let's just do this. I'm going to just copy this here, and I'm going to paste here. So LLM2, let's use GPT-4 and let's ask this question using that same context, right? And let's see what this is gonna say. So okay, so it says based on the context, I don't have specific information about how long Daniel has been on Earth. You haven't given me details about Daniel's age. The fact that he has 2 children doesn't directly inform us about his time on Earth, since people can have children at a wide. So now you can see that GPT-4 is obviously more intelligent, right? But yeah, you can see the limitation of this, right? So now let's take, and the reason why this is not working fine is because we are basically doing a word-to-word match here. Now let's take this same query, yes, and use ChromaDB to do a semantic search instead. And once we run this, let's see what the result is going to look like. Can you see that ChromaDB was able to fetch the 2 most useful documents? I don't know how ChromaDB is doing this exactly, right? Because of course it's a Python module, right? But I can tell you for sure that it's using a combination of AI and semantic search from mathematical operations to find the best results. And with this, we can actually draft out a better function to do a context search. Now, one more thing before we, proceed to drafting a better function for the context search is we can actually adjust the numbers of documents that is being returned. So it has been returning 2 to us because we said 2. So if you change this to 1, it's going to return 1 that it is the most related to the question. So let's run this and let's run this, and you can see that we got this. Now one more thing I need to specify is that you can see that what ChromaDB is returning is actually a Python dictionary with different keys, but the one we are most interested in is the documents, right? So we can just simplify things further and just say print out only documents, right? And this is going to give us the documents in this case. Alright, so let's proceed. So what I'm going to do is this. I'm going to I'm going to put all this into our context search function here. So we are no longer using this word for word matching here. We are now using the ChromaDB, and the query is basically going to be the question, right? And we do no longer need the context list anymore, because now automatically we are fetching from the DB, and then we are going to return. So now with just 3 lines of code, we've created a very much more efficient and intelligent context search, right? And I'm going to just do one more thing. Yeah, I think we are good. So now let's run this and let's see how long has Daniel been on Earth. There's an error here. Context search takes one. Oh, good. So now we no longer need to pass the context DB here. We just need to pass the user's question, and then we can run this. So now let's see what GPT-4 is going to say now. Now we believe that good. So you say based on the context provided, Daniel is been on Earth for 45 years old. For 45 years, which is very correct. So we can just change this to 2, so we can give more context. So the idea is that we have ChromaDB gives us the ability to control the amount of documents we feed into the LLM. So in most cases, just one document is enough, but sometimes you probably want to have more than one document, right? So yeah, that's it. So yeah, so I'm going to combine all this into one single code, and I'm going to round this up. So one thing I want to tell you, or I think is very important, is the moment we added these documents here, it has been saved inside our collection here, inside the data, right? So it means that if we start a new project, we can still load this database. So what I mean is this: I'm going to create a new file. I'm just going to call this random.ipynb. I'm going to split my screen here because I want to show you guys something quickly, and I'm going to copy some few things here. I'm going to copy this entire code here. I'm going to paste here, and of course if I run this, I'm going to get error. LLMs, run this, I'm going to get a problem, and the error I'm going to get is going to say something like DB is not defined, because we've not created the DB objects here. So I'm going to import this at the beginning here. Then this time around, I am not creating a collection. I have created a collection before, and because I'm using a persistent client, the collection has been saved on my system in this context folder here, right? So what I want to do this time around is to get collection, not create collection. So basically I am just going to say, I'm going to copy this, I'm going to paste this here, then I'm going to say db equal to client dot get, this time around get collection, and I'm going to specify the collection. In this case it is Daniel. So if I run this code, I have the collection now, and then DB here is now a valid object that can be used to query. So run this and run this, and we should be able to get our response from GPT. So you can see the response. Yeah. So it said based on the context provided, which is this, Daniel has been on Earth for 45 years old. So we have built a very intelligent RAG system, right, that uses a ChromaDB, which helps us to perform semantic search based on embeddings created using the strings in our context, right? And now, irrespective of how the question is asked, the system is able to answer the question properly. And let me show you something interesting. Now let's assume you are asking a question that basically needs two of these contexts to be answered. Something like, okay, let's do something, right? Before we return the document, let's also print out the document so we can see exactly what document is being used to answer this question, right? So I want to ask a question that would need two contexts here to answer. So I'm going to say, how long has Daniel been on Earth, and where does he live? I think this makes sense. Where does he live? So if I run this, you will see that the two contexts very perfect that answers this question was extracted by ChromaDB, and ChromaDB then passed that context to GPT-4, and GPT-4 was able to answer the question. Daniel has been on Earth for 45 years and he lives in San Francisco. This is pretty interesting. This is actually good enough for a RAG system, right? But there are other advanced things and advanced techniques we can do to improve this system. However, this is actually very good enough. You can use this personally. All you need to do is just to, ensure you have. As a matter of fact, at this point, we no longer need these parts anymore, because now that data has been stored inside our collection. It's actually not coming from. So it's actually coming from this DB here, right, which already has the data, because we did the adding of data in the previous code. So as long as we are in the same directory where this context is, we are going to be able to get it. So if we run this code, it's going to work pretty fine even without that context to be in the in our code, right? So this is good, but in our next class I'm going to teach you how to wrap this into an actual chatbot where you can ask questions to and fro. So it's going to be a complete conversational chatbot, right? Because right now we have to keep running our question one at a time. We want to create something that is like a input output, stuck in a loop, right? So we can have continuous conversation with the AI. I'll see you guys in the next video.